Merci Lisa. Thank you. Et donc là, nous passons à la deuxième intervention de Monsieur Couture sur les facteurs humains et l'impact de l'exploitabilité sur les activités du call center.
So today we're going to speak about human factors. By a show of hands, who in here is familiar what the general field of human factors is? Okay, that's sort of what I figured. So human factors is a field of psychology. So in general, the easiest way to explain human factors, and this is a real quick overview because we're going to get into a lot more detail in a minute. Human factors is, as we're going to talk about it, is usability. So it's how do we make things easier to use, more intuitive, less error prone, and so forth. So we're going to go into what is human factors. A lot more detail than I just did. Why is human factors important? Why does it matter? Why are we talking about it today? How it applies to contact centers, how it can benefit your company and your customers for that matter, and then some keys to success as you try and bring usability into your culture within your company. So first, what is it? I'm just going to read this. It'll be a little bit easier to do it that way. So human factors is the study of how humans interact with their environment and the application of solutions that solve problems, mitigate against errors, reduce injuries, and improve various performance or other experiential characteristics of the interactions. So what we're trying to do is improve systems in this case, and how people interact with those systems to make them less error prone, to make people more effective, to make information clearer, that we can get it across in a clearer manner, and so forth. Human factors is there's two divisions in human factors. You have engineering and you have psychology. And basically the two are human factors engineering is more on the physical science side, psychology is on the psychological side. So there's not always hard lines between the two when you go into schooling for these. A human factors engineer will take psychology classes, a human factors psychologist will take classes that are related to the engineering side, especially like computer sciences and things like that. So it's not, the lines between the two are a little blurry, but in general, one leans on the physical side, one leans on the psychological side. So when you get into engineering, you focus on things like repetitive motion, range of motion limitations, the physical characteristics of how things are laid out. If you think about being in a car, where your switches are, even how your steering wheel is positioned, where your turn signal is, how the gauge cluster behind your steering wheel, how that is laid out. So all of those things are human factors engineers generally are the ones who deal with those. Now there are psychological aspects of those too, so sometimes the human factors psychologists will come in as well. But in general, that's your engineering side. Airplane cockpits are another example. One of the things that we've dealt with over the past is what we call the 747 problem, where you have, in a 747 airliner, you have just enormous amounts of gauges and buttons and switches and all kinds of readouts and everything. It's extremely easy to get overwhelmed with systems that are set up like that. So we don't design websites like that, for example. Some of the systems that you use in call centers sometimes might feel like that, though, especially when you're navigating between many different ones. So then you know how laptops are laid out. A nuclear plant control room is another place where a human factors engineer would be involved. They look at things like eye strain, auditory limitations, or things like whether something is too loud, too quiet, is there interference that's coming from somewhere else. So it's kind of more on the physical side, because on the psychological side we get into auditory issues too, but it's a different perspective. And then fatigue, so particularly physical fatigue, so even eye strain, things like that. So, well, human factor psychology generally focuses on the psychological environment. So we have a lot more here because we're going to talk about this a little bit more today. So knowledge acquisition and retention would be a human factor psychologist issue. Information processing in terms of time and accuracy, understanding versus simple factual knowledge, because there's a difference there. You can know a whole lot of facts but not understand them. Short-term and long-term memory limitations, visual perceptions of contrast, color blindness, real and apparent motion, things like that. Auditory perception, so here, you know, again, a little bit ago we talked about loud versus quiet, and interference from the outside, and here we're talking more from the auditory side, like tone of voice, comprehension, which is something we've dealt with many times since we've been here, and I'm sure both sides. So interference also there. So here's one that kind of crosses that border. So we talked about interference on the physical side. You also have that on the psychological side, where things can interfere with your understanding, not just with hearing in particular. So then we also get into information architecture, so how information is organized. If you think of librarians are experts at information architecture. So how do you organize information? And in a system, generally there's several different types of information architecture. So you'll have your main sitemap, or your how your system is laid out at a high level, like the hierarchy of the overall system, but then you also get into information architecture in a single screen or page. So that's where you look at headers, subheaders, and things like that. In a website, you'll have headers, subheaders, paragraphs, you might have an aside. All those different things are part of your information architecture. And that can drastically affect how you understand and perceive the content that you're trying to access on the page. And then fatigue also, so this is another one that was on the human factors engineering side. You have fatigue, but that's physical fatigue. So here we're talking about cognitive, what we call cognitive load. So as you process information over time, that's very strenuous on your brain and how you think. So on the psychological side, we look at things that will strain people over time, and how we can reduce that. Now, this is a graphic that we created a few years ago, that this field of psychology has a lot of fields do this, but has a lot of different aspects to it. So we have human factors down here at the bottom, and technically speaking, this isn't what we're going to be talking about today, which is a little tricky here, so I'll explain this. So typically speaking, on the human factor side, you're generally dealing with things that are more physical, okay, in the physical environment like we've gone over. So you have fields within this are things like industrial psychology, industrial engineering, operational engineering, and here we have like workplace layout, anthropometry, sorry. It's probably going to be tricky to translate. And then as you go up, things get less physical. So here we have physical, and here we have psychological. So as you go up this, we get more onto the psychology side. So you go from human factors to ergonomics, and again, ergonomics, think of how things are laid out in cars. So physically, how easy is this to use? Here you have bioengineering, things like biomechanics, decision-making, stress. We get into some that start to blur the line here. And then once you get into engineering psychology, which technically is what we're talking about today, you really get into some experimental psychology, biological psychology, social psychology, and so forth. Displays, workload, training, those are kind of more where we're going to get into, even maybe some communications that are, that's this upper realm here is where we're going to focus. So this is a complex field like many fields out there, but I want to give you kind of an overview of it so you sort of understand the different things that we're talking about here, because it's a field that a lot of people don't know a whole lot about. So why does any of this matter? And actually, just to give you a real quick background, human factors started out in early 1900s, where there were some psychologists who were working in the United States and dealing with people who were in coal mines. Not just psychologists, but these coal miners kept getting these injuries, and they couldn't figure out why they were getting these injuries. So they started looking at the tools that they used, and they realized that in different aspects of the coal mining industry, they were all using the same shovels. And they started to design shovels that were more appropriate for certain tasks. So you might have a shovel with a sharp point on it to do something where you're digging into something and you break it up. You have a shovel with a more straight end on it to do other things, and one that's maybe wider where you're picking up large things that have already been broken up and dumping them into some kind of a container. So they started doing this, and then all their injuries started going down, their fatigue started going down. And so that's kind of where this started. It was people looking at a problem and figuring out a better way to do it. Now, as you look at the course of history, those types of things have happened many, many times before the early 1900s, but this is where the actual field as a discipline sort of started. So why does all of this matter? Oftentimes we assume that what we think is the norm. I mentioned this the other day in a previous talk or one of our sessions up here that I have designers who come to us and say, well, I've designed it this way and I can use it, so therefore everybody else should be able to use it. And that is definitely not the case. So we're often incorrect in our assumptions, and those incorrect assumptions lead to inefficient and error-prone systems. Those error-prone systems and inefficient systems then lead to higher cost of operation. So that's a bad thing. We want to reduce operational costs. So as we get into solving some of these problems, we can do that. Human error is a pretty massive topic within human factors, engineering, psychology, and so forth. The range of consequences within human error can be minor, or something as small as incorrect keying of information into a CRM. That's not going to cause any disastrous effect. It probably will be pretty minimal, may affect 1 or 2 people, but not a horrible problem. To the other side of the spectrum where you can have nuclear meltdowns, so you think of things like 3 Mile Island in New York, and then Fukushima just in the past few years. And there's a quote that I have here that came from the Investigation Commission on that accident, and it says, "We believe that the underlying causes of the accident are to be found in the organizational and control systems that supported wrong decisions and actions." That's all human factors. There are things there that, had they done the right testing along the way, they could have solved. And it was interesting when you look at that study, probably too much of an aside, but there are actually cultural issues that caused that too. So people were afraid to speak up, and they just kind of did what they were told to along the way there that had to do with the culture. Oftentimes these errors are caused by simple problems. So a lot of times the way that we fix problems with systems isn't by doing these massive overhauls that take years and years to do. A lot of times there's small tweaks that you can do that make enormous differences in human, and the ability for us to use those systems well. And a lot of times those can be prevented by controlled testing. Human factors also help us to find hidden challenges. So oftentimes, experts are the ones who create these systems. And experts then aren't the ones who use those systems. So you have novices who use the systems. Well, when I, as an expert, design or develop a system, and then I hand it off to somebody who isn't an expert. Now, we have training that's involved there and everything, but there are a lot of things that I assume other people are going to know and be able to use easily, and a lot of those assumptions are wrong because I forget how much training and how much time it took me to get to this level of expertise. So it's very important to do testing because those help to find those biases. And then research can often help to solve those common challenges. So, let's see, I'll just skip the rest of that. So, these are all, usability testing is also very cost effective. So, one of the challenges that we have a lot of times is actually convincing people that usability testing will pay off in the end. And when you look at studies that look at the ROI on usability testing, you see that for every $1 that you spend on testing, your ROI, your return on that investment is $2 to $100. So that's a minimum, you're going to recoup double what you put into it. So it's clearly worth spending money on. So how does this apply to contact centers? First of all, there's a whole bunch of different reasons we're going over this at a high level. But first of all, if you look at knowledge management systems, you have shared knowledge that multiple people, hopefully all the people in your company, are going to have access to. And you get consistent communication across your customers. So as a customer calls in and the agent tries to deal with that question, if they don't know that question, well, regardless if they've even seen it before within the knowledge management system, they can quickly go into this knowledge management system, find that answer, and give the exact same answer that another agent gave some other time. And so you have consistency that you get out of it. You have lower reliance on fallible human memory. So people, we think oftentimes that we remember things a whole lot better than we do. So if you ever have somebody in your life who is a storyteller, and you hear them tell a story multiple times, a lot of times you'll say, that's not what you told me the last time. There's little things in it that are different. And most of the time, it's not somebody who's trying to deceive you or anything like that. It's their memory is fallible. And the funny thing is yours may be too. So you may think that's different. In reality, if you went back and you had a videotape of it, they were right. So you don't know who was wrong when you're in that situation oftentimes. It also builds and changes over time. So a knowledge management system, you can continue to build that up and grow, and it can scale. So it can scale essentially in an unlimited way. Now the trick with that is as it builds and grows and there's more knowledge in there, it also can get more difficult to navigate. So you have to also figure out how to make it usable as it grows, which can be a major challenge. So system factors to consider. So again, it's accessible to all who need it. It needs to be. It should be integrated with other systems. It needs to be easy to update. Those updates need to be real time or close to it. We'll get into why here in a minute. Proper information architecture, as I said just a second ago, is critical. So as that system grows, it needs to be organized in a way that allows it to grow and that information still be easy to access. Quick and accurate search functionality is a must. Today we have a lot better tools for that. You start typing in a box and you have a drop down that comes up, so you have suggested results and so forth. So sometimes you can type 3 letters and there's your one. You just click there and you don't have to type another 15 letters after that. So those things can help. Now those search results need to be accurate as well. So there's optimization you can do on the programming side to fix that. Training resources. This makes training resources available. So as you do training is also, it makes your training consistent also across people as they come in, because you have it all documented in this system. And then you should have some type of moderated suggestion submission. So I'm a CSA, an agent who is on phone. I have this question that I look up. I look at the answer, and I know that there's been a change somewhere along the line in a policy, a procedure, or so forth. And so I see the answer. I know that it is mostly right, but not quite right. I need to have a way to suggest an update to this. So now, you don't want them to put that, you don't want them to be able to change the system itself so that it's just instant, because they might be wrong. So what you want them to be able to do is have a button there that says suggest change. They write in what they think it should be. They submit that. That goes to a moderation queue that a supervisor or manager has access to. They might there's some kind of protocol you put into place there that moderates that, and then you have an approval process and so forth. But that should be built right into the system. Usability studies on systems, including systems integration. We'll talk about that a little bit here. So traversal of multiple systems with a whole bunch of different interfaces can be very confusing and daunting, just difficult to do. So you get into these systems and you sit there and say, where am I? I have no idea how did I get to where I am now? Where do I even go from here? And how do I get back to where I was before? Early in the internet, there were people who would do things to actually disable back buttons in browsers. It was a horrible thing to do for usability. Now there are ways to get around it, but why would you want to do that in the first place? It made no sense. So how you set up your navigation between these systems is crucial. Studies can assess how the impact of system changes and integrations. So we look at things like memory load. So short-term memory, particularly when you're going through, what was the previous screen? So I'm on one screen, I just entered information into it, I go to the next screen, I have to remember what I just did. And short-term memory is very volatile. It can go away very quickly. So how do we set systems up that make that load on users a lot less? And sometimes you can do it without any load, depending on the system. And then how you also have to remember your progress through the process that you're doing. Am I on step 4? Am I on step 2? Where am I in that? And that can be very difficult to do. So we look at wayfinding, for example. So how you get from one point to another. So if you think about when you get directions from a friend to meet them somewhere, some people will say, go to this street, turn left, go to that street, turn left, go to this next street, turn left, and everything's done through right, left, so forth. Other people will say, go to this restaurant, and at that intersection make a left, and then go to this other landmark somewhere else, and go straight through that intersection, and so forth. So they're using landmarks. And then other people have a mental map in their head where they have a map, right? So they're Google Maps, but it's all in their brains. So they will try and convey it in that way. So wayfinding varies by person, and some people will mix it up, and they'll say, well, go to this restaurant, make a left, then go to your next light and make a right, then go to this road and take a left. So they mix those things up. So how do we do that? And that also is as we navigate through websites. If you think about a website, or I'm using a website, but this is relevant for systems as any kind of system. You'll have generally a search box on that website. You'll have a main navigation. You may have sub-navigation. You have links within pages. You have a footer that typically has links in it. So you have all these different ways that you can get to the information. And the reason why we do that is because some people go to a page, they go to search, and they just search. They don't even look anywhere else. Amazon is a great example of that. Most people, when they use Amazon, instantly go to the search box. They don't even use the rest of the navigation. Google is a wonderful example of this. They literally got rid of all of any other kind of navigation, and all you do is go there and you know what you're going to do with Google. Of course, in browsers now, you just go up to the browser and do it in the Omnibox. But when you compare Google to something like Yahoo, you go to Yahoo, and yes, they have a search box, and they have a million other things on the page, and it's kind of overwhelming. That's part of the reason why Google is Google now, and everybody says, I'm going to go Google something. You don't say, I'm going to go Yahoo something. So we get into memory load. You also look at short-term memory compared to long-term memory. So short-term, again, you're in that process type thing, going from page to page. Long-term, you're looking at things like how do you relearn when things change. So you have this long-term memory, and just to give you a quick overview, short-term memory lasts up to about 30 seconds. Sometimes people will say a minute. Short-term memory, that's how short-term memory is. So 10 minutes ago is not short-term memory. 10 minutes ago is actually long-term memory, but it's interesting because long-term memory that is that short tends to also be forgotten quickly. So long-term memory on the short term is also very volatile. It's those things that, so I was trained on this multiple times, there's all kinds of repetition during training, and then you have it down, so now you've remembered it for 10 minutes, 20 minutes, an hour, 3 days, 3 weeks, you're 3 months into it, and now there's a change. So this is really long-term memory, right? You've done this for months and months, and now something changes. So how does that affect the person who's using that system? I went all over that already. So studies can, again, to continue on here, the studies can assess these impacts. You also have inconsistent and unclear labeling issues. So when you go from one screen to the next, if you have the same piece of information that needs to be put into 2 different places, and you label that 2 different ways, even if it's a fairly slight change, that's a problem. So you need consistency between all these different systems. Or if you have one system that was developed by one company and another one that was developed by another company, those 2 pages may be drastically different in how they label things because they were 2 completely different companies who did it. So how does that affect people? You have UI specific issues. UI is your user interface that you're building. UI can also stand for user interaction, so there can be some confusion there. Speaking of inconsistent labeling. So you have the size of elements. How big are text boxes or buttons and those kinds of things. You have the color of elements. So color blindness affects, I think it's 5% of men, if I remember correctly. It's a very small percentage of women. It's 1% or less of women. But 5% is a fairly significant number when you think about how many people there are in the world. Order of information, so here we get into a little bit of the information architecture. So you have 2 systems. One orders information 1, 2, 3, 4, and the next one that's 1, 4, 3, 2. So when you're going between those, you're going back and forth and trying to figure out where things are going to be, so that can cause problems as well. So how can all of this benefit your company? So first, it can improve systems user experience, so your UX. So it reduces stress, lowers onboarding time, mitigates against human error. In human error, when you do that, then you have inconsistent information often that is put into the systems and so forth. It also helps boost employee morale. So when you have systems that are difficult to use, how fun is that? It's not fun at all. You get very frustrated. It's just a pain, and you think, if this were only like this, I could do it in half the time, right? So then you get frustrated. So when those systems are easy to use and people are just going through them and super fast, they're actually much happier to do that. It also elevates your customer experience. So successful systems lead to enhanced customer experience as system efficiency and effectiveness elevate their ease of interacting with customer staff, contact center staff. So as you are a customer, I'm interacting with you, and you're having difficulty with your systems, I have to wait longer. And you're sitting there, well, I don't know what's going on, my computer's slow because the database isn't responding, because there's something, there's a problem there, and there's a million different things there. So it actually enhances your customer experience as well. It also improves efficiency. Efficiency is good. We do things faster, we do them better. That reduces cost of operation. You can have fewer people doing the same task that took more people to do earlier. So types of usability testing, this is a very big topic, so I'm just going to go over a few things, and I'm probably going to do this. How am I doing on time? Okay. So three basic differentiators here. So we have moderated in-person, moderated remote, and unmoderated remote. So moderated in-person is the most costly. Typically, you're going to test a lower number of participants, so somewhere between maybe 10 and 100. You could test 5. Generally, this is a big investment, so you're generally going to want to test more than that. You're usually looking somewhere between a minimum of 20. 100 is actually quite a bit for this type of testing. The testing period is the longest here. There's a lot of setup that has to be done. You have to find your participants. You have to incentivize these participants as well. You're paying these people for giving them some type of a benefit for doing this. Your control over the participant selection is very high here, which is good. So you can say, I want females between the age of 32 and 40, and whatever else, what their education is, and all those different things. How familiar they are with systems and so forth. You can even say, I want them to have familiarity with these systems. Okay, and you draw from your pool that way. And again, depending on what kind of expertise you want, your cost is going to go up. So moderated remote. So here, what this is you have a human factor, some kind of a psychologist involved in this, and they are actually sitting down with this person performing these studies in person. So you have both a psychologist, you have all the participants that come in, you do this one at a time. This is not focus group. If you're familiar with what a focus group is, this is not a focus group. This is not where you bring a whole bunch of people in and you ask them these questions all at the same time. The reason you don't do that is because focus groups often give you groupthink. So you have one person that is very vocal, or two, and out of, say, 10 people who are in the room, and everybody else just says, yep, I agree. And it doesn't always happen. But you don't want to even have that happen at all here. So it's the participant one at a time with the moderator. Moderated remote is also the participant one at a time with a moderator, but you can do this remotely. Here you're using screen sharing or some kind of computer monitoring software, something like that. There's a whole bunch of different options to do this out there. Typically, you're going to test lower number also, so you're still within that 10 to 100 range. Generally, again, you're talking about 20-ish, 25, 30 people. Testing period in terms of how long this takes is sort of in the middle of these. So not the longest, not the shortest, somewhere in the middle there. And then your control over participant selection is also high here in general. You can have somewhat lower than moderated in person, but generally it's almost the same. Unmoderated remote, there are systems that you can subscribe to where you can do this remotely. There's one called Loop 11 that is amazing. And they have all kinds of capability. If you're interested in that, it's just Loop, L-O-O-P, the number 11, 11.com. I'm pretty sure that's what it is. So this one you can do remotely. There's several different options out there for this. And in general, they're very cheap to do. Here, the wonderful thing about this is you can have a lot of participants in this. So you can do, most of these allow you to do up to 1,000 participants at a time, and they can be done concurrently. So you can, in one day, you can test 1,000 people. It's hard to do, it is hard to do, if you have one psychologist doing this, it's difficult to do even 6 on one day. So from 5 or 6 to 1,000 is obviously a big difference. You can even do, depending on the study, you can do 1,000 in just a few hours. It's simple to set up and run. It's very short. And the bad thing about this is most of the times you have little to no control over your participants. Now you can say, they have a form that you fill out. I want people between these ages and so forth. But you don't interview those people. There's nothing that you have no control over that. So you're reliant upon them self-reporting. What their age and income and all those kinds of things are. Types of testing, in general you have problem discovery, benchmark, competitive, I think there's some more here coming up, but problem discovery is the most common. This is where you want to test the system to see if there's something wrong with it. And then if there's something wrong with it, how do you fix it? Benchmark testing, that is when you want to know where you are right now. What's the usability? How easy is it to use? Is it to use my current system? That's important because if you're about ready to make changes to it, you want to know, did I improve or did we have problems that we inserted into the system? And then the last one is here is competitive. The purpose of this is to do what I just said. So you compare against your benchmarks. You also have eye tracking studies. So this is when you sit in front of a screen. There's a million different, probably not a million, sorry. There's many different options for this too. So you have some type of a sensor that tracks your retinas, your eyes, and it tells you where people are looking on pages. So if you've ever seen heat maps of websites where you'll have red and it's like people are really looking right here, and over some places it's white, they're not even looking there at all, and some are orange and yellow and whatever. So what this does is it helps you to understand what parts of the page are paid attention to the most. Okay, because where our eyes go, that's where our focus is. I can't tell you what's going on over here right now. Over here, sorry, I couldn't see a little bit in my periphery. So, but if my eyes are focused on something, I can tell I'm looking at that camera right now, and I'm looking at the red light on the camera, right? So. This can be important because what it can identify is either what are the most used things or what are the things that actually cause confusion. Because some people, they'll focus on something because they're going, I have no idea what that means. So I have to focus on it to figure it out. And just as a little aside, it's interesting because when you look at how people use systems, we don't do this. I'm going to read, I'm going to read, I'm going to read, I'm just reading across and whatever. If it's Arabic, it would be the other way, right? So, that's not how we use systems. We use systems like this. It's all over the place, okay? So when you do eye tracking studies, it was interesting when we first started doing them because we kind of assumed, well, people just read, right? And we don't. That was immediately found that out when we were doing this. The last one here is learnability. So the purpose here is to kind of quantify that learning curve of participants as they use the interface. So you have either a brand new person with a new system and you want to try and figure out how quickly they learn this new system, or you have a well-known system that you've made changes in and you want to figure out how easy people pick up those changes. I'm probably running out of time, aren't I, by now? Okay. So hopefully I can get through these quickly. So tree testing, I'm going to go fairly quickly. Tree testing, this is when you're testing information architecture, so how things are laid out in terms of the information. And the level of this is at the sitemap. So this is the overarching, if you think of a web page or website, would be the overarching sitemap. Here you're looking at, essentially, this is what you're looking at. You're looking at hierarchy. When you get into card sorting, this is when you literally take paper cards. Now you can do this virtually also in digital forms.
The kind of channel from where to where?
For the tree testing?
Yeah.
Yes, yeah. So it's like how you get from one place to another. Actually, it's not that. Tree testing is the structure of all of that. Navigation then would be how you actually get from one point to another. You see the difference? Tree testing is just looking at the structure. That's all you're doing is looking at the structure. You're not saying there's going to be a link from here to here, a button that gets you from one place to another. So there's a subtle difference there. I can get into specifics later because we're running out of time, but because there are some important distinctions there. Card sorting, again, you may have note cards and you just put one thing on each one of those note cards. So, you know, homepage, contact us, about us, services, whatever, and then you have you do that for a whole bunch of different things, and then you take those cards and you give them to somebody and you say, organize these for me. And then how they organize them starts helping you to understand how people look at the information that you've put before them, and you'll see certain things will start to go under, they'll start to build their own hierarchy. And that helps you to understand, okay, this is how we should set this up, because this is generally how people understand this information. A-B comparisons, this is where you have one layout, layout A, you have layout B. You look at how you do testing on both of those, and you see which one is the better one. You have grouping these in two groups, simple and complex usability testing. We'll get into why here in a minute. So simple, you have lower cost, it's quicker to do, it's in a more natural setting most of the time because you're generally doing this in front of a user's computer and so forth. Tools to do this are generally low cost, like card sorting. It's literally just paper and pen, you know, that you write on with. Lower control over the environment is associated with this to some extent. Depending on the study, the results tend to be a little bit less generalizable. These are usually really quick. You're not, they're scientific, but not stringently so. And then they're easy to perform at multiple times during implementation development. This is huge. This is absolutely huge. This actually is also why it's lower cost and shorter timeline, but, well, they both go into that, but we'll get into more of that here in just a second. So complex is essentially the opposite of all of these. So it's higher cost, so it's a longer timeline. You're usually looking at a laboratory setting, which is not natural. People sometimes even do things in the laboratory just because you're in the lab. It's lots of costly equipment is used. This is where you do eye tracking studies generally. Depending on the study, the results do tend to be more generalizable, which is great. They're a lot more scientific here. So again, eye tracking study, the science behind that is very robust. So there's you have a lot of real metrics that come out of that you can test against. It is difficult to perform multiple times during implementation development because you have to go to a lab, you have to get all your participants, you have to figure out how you're going to incentivize them and so forth. So a lot more goes into this. Keys to success here, this is very important. You have to be committed to usability or it's not going to work. This has to be something that your overall organization is committed to. Any worthwhile endeavor, you're going to have commitment, but this is particularly important in usability because if you start down this path and then stop or only do it in a half-hearted way, you're not going to get very good results out of it. It is key to test early and often. So one thing to remember, developers, engineers in this room, how easy is it to change a system after you've developed it for a year? Not very easy. So what you do is you start out with a prototype, you test it. You go into your alphas, your various alphas, and you test during those things. If you have a year-long project, typically Design phase, you're going to want to do some usability in there. Maybe only one round of testing during design. As you go through development and you start getting to the point where you actually have prototypes that are ready, in a year-long project, you probably want to do at least 3 usability tests. The more, the better. If you can do 5, that would be great. Because what that allows you to do is it helps you to find the problems very early on in the process, which means you can save time and money as you go along. So the way we look at it is as the process goes on, the time and money it takes to correct it goes up like, it's exponential. And remember that simple testing with 5, 10, 20 subjects can be very, very useful. Even one subject who isn't the developer and designer can be useful. Now that's very hard to generalize because you're only talking about another person or two, but it's still better than doing none. So start simple, but also it's imperative to continue with that simple testing as you go along, so don't stop, just keep doing, like I said, don't just test one time, test at least a couple of different times. The simple side, the simple option of doing this is less costly, it's easier to implement, quicker to perform, and it can still give you very valuable insights. So don't think you have to make this complicated and go to a lab to do this testing. You don't have to do that. It can become complex very quickly, so again, start simple. I'm going to keep saying that. Develop a usability strategy. You should have an overarching strategy for the company as a whole, but then each project should have its own strategy individually, because each project is going to vary, and you may have to tweak that overall strategy a little bit. Find the right partners. I worked at LexisNexis. I worked there as a human factors engineer for a while, and they had a staff. We had probably 12 to 15 of us in the Dayton location. We worked with guys who were in and gals who were in Germany, England. I think we had some in Japan. So we had a big team. That is extremely rare. Most of the time you're lucky if you have one. And most companies don't have any. So find the right partner, and that right partner will work with you, your teams, your budget, what kind of projects you have and all of that to help you even create a culture of usability within your company. It's great if you can get this into upper management, because if they buy in, they will help everybody else buy into it, and it'll be successful that way. Questions? No questions? All right, great, thank you.